right, hello. We'll get started in a few minutes. In the meantime, feel free to drop any questions or thoughts in the chat, and we'll get going real soon. Thanks for coming out on a Sunday. Oh, focus. And my apologies for the background vibration and noise. My office is directly next to the laundry room, so while that is going, it kind of makes some noise in here. I'm going to put out a little note on social media, and then we can get started. Okay. Hi, Mitch. Welcome to the stream. It still has not updated my users in chat, but hello. Since I've gotten feedback from previous streams, I decided to change things up a little bit today. I have changed my primary screen to like 1/4 of the resolution so that everybody can see it clearly. It's gonna be really huge for me because this is like a 30-inch screen. So the normal size text is going to be a good like half centimeter tall, which is really big. I'm not used to that, so I'm going to have very little screen space. But Ben, bear with me, and we'll hopefully do well. Thank you, Mitch. Yes, I don't know that you were here last time, but I did figure out that previously I had the microphone input on there twice for my primary scene, and I didn't understand that with OBS you have to it will always take the mic, so you don't have to specify the microphone as a separate input unless that is picking up something that's not your primary voice. So anyway, no robo this time. No robo last time, actually, once I figured that out. Well, thank you. All right. And all right, just another minute or so, and then we'll get started coding. Hope everybody's had a good weekend. Yeah, I need some like some chill vibes going on in the background. Yeah, I agree. I know some streamers when they're doing whatever, they'll just have music going in the background. But I think that I would find that too distracting. I'd get too into it. So um, wouldn't want to turn it off. Okay. All right. Well, let's talk about today's agenda. So I'll pull up my primary screen here. So last time, just to review, we talked about telemetry and tracing. We added the telemetry library. We added open telemetry. We also added the path params middleware with a modification. And those were so that we can, like anything production ready needs to have instrumentation on it. So we have the instrumentation now. There are still some open things. We did not, for example, actually get the open telemetry tests working. So I have some ideas on that today, and I would entertain any ideas that you all have in the chat. Please throw them my way. I think probably what we'll do is we'll do some tracing. We might set up the app to run in dev mode with OpenTelemetry on and see what happens. So I'm considering Observer, for example. But the main thing here is we need to get some visibility into why the spans that we are creating in our client we're not getting to the test through the exporter. One other side thing I wanted to touch on is, I brought in, maybe it was the first session, I brought in Michal Muscala's decompile, which is a great little tool if you want to understand what your macros are doing, or if you understand what the Elixir compiler is doing. So we'll revisit that, and I think that in the first session I didn't have it set up the way that I would like to be able to show you what comes out of our crazy macros. And they're not even that crazy yet. They might get worse. So we need to make sure we're generating the correct code. Decompile is a great way to do that. And then finally, hopefully we'll get to circuit breaking. If we don't spend too much time fixing the open telemetry tests, which I suspect will probably take a little while. But let's get started with the test suite cleanup. And so let's bring back up my Z window. This is week 2 or more of using Z. So still a little bit unstable, but I've been enjoying it for the most part. And at the very least, running the language server in the background does not hang my editor anymore. So that's a bonus. Just one or two brief things here. I was going to update the README, put some badges in there. And we did last time basically do the telemetry and OpenTelemetry integration. So if we can check that off. This has not been committed yet. So I'm just going to really quickly update that. Flagged recent progress. And then I'm going to push and we'll see if we get, there we go. See if we get those badges. Okay, so the hex badge is not working, probably because nobody downloads it. Why am I triggering you, Mitch? Please explain. But okay, so we've got our badges updated. Okay. And if this is too big or too small, please let me know. I will change the resolution and we'll do something different, or I'll change the font size. Okay. So on our agenda, let's start cleaning up the test suite. I think that it was fine to do it the way we did first, which was just to have everything in one test suite. But I think as we get more features, we're going to want to test them a bit more in isolation. And to be honest, if I run mixed test here and I get all this goop, I really don't want that goop in every. Hi Sam, welcome. I really don't want that goop in every output of mixed test. So let's see if we can clean some of that up. And I'm gonna start with splitting this into separate modules. So let's make a new folder here. Okay, that's not what I wanted. New folder. There we go. So I'm not gonna make these completely parallel with the lib tree. Somebody slap me if I should do that, but I'm going to say open telemetry test here. And let's move the stuff that we need for open telemetry in there. And can't have that goop. No, you can't, Justin. Okay, so we're going to copy this. And let's say hardhat dot open telemetry. And then we'll get the stuff in here that was related to that. So we'll just make our own test client. And the nice thing too about separating these is that we can, the things like this open telemetry test that need to have exclusive control over the run, because, for example, they are using setting the application environment, which is not safe to do. Then we can do this in in its own test suite, and then we can make everything else async true, and then our test suite will run a little bit faster. Okay, so we've got this. So we are not going to require record. We're going to put this back to async true. We are going to remove that. We are going to degoop this. And then we're going to move these two tests over here. Okay, so now we have a test suite that is specific to the open telemetry integration. Yeah, Mitch, you can tell if they used capital application or if they used the colon prefixed Erlang module. Honestly, it doesn't really matter in the end, but yeah, you can. And I think what I did last session, you missed it, Mitch, but I tried to switch them all over to the Elixir versions, and then I was like, oh, it's put env, not set env. Why did they change that name? Anyway, so I decided to just copy paste and not worry about it anymore. But I believe a lot of that was just copy pasted into multiple test suites in the open telemetry contrib. So, okay. And then let's make a new one for, let's put the telemetry over in there. Not open telemetry, but the other one. So let's make a new file, telemetry test. Okay. And let's cut that out and put it in here. Oops, wrong one. And we're going to need to do some of the stuff that is up at the top again. Just copy that. Okay, and we'll have the same setup. Now you may notice that we're doing the same stuff here. So we may want to, at some point, make our own case template, in which would like reduce some of this setup stuff that we have to do, and we could just have like hardhat.case. But maybe we'll leave that for later if we have extra time. I mostly just want to shuffle the deck chairs a little bit here. Okay, and then finally, let's make a one for path params. It's not all that big, but let me make sure we got this correct. Okay, so I have all the setup, we have the client. Cool. So let's just copy pasta this, and we'll rename it path params test. And let's pull out this test and put it in here. Okay, so now the Hardhat test is just down to connection pooling, which is probably a good place for it to be, because that's the only shuffle, Sam, my apologies. It's the only thing that really is related to the top level, I think. So the rest of it is related to middleware. Let's, before we go any farther, let's just run the tests and make sure that nothing broke. Okay. So we're just, notice it didn't print out, because we skipped both the tests in the OpenTelemetry test. Notice it didn't print out this stuff, because we're not starting and stopping OpenTelemetry. And on the tests that don't use anything related to it. So that's already an improvement. I've been wanting to deal with this. I think this is a pretty simple fix. So let's go over there and fix that. So that is in the telemetry test. Now what it's complaining about is that we are attaching a handler, which is an anonymous function, and they much prefer that you attach handlers that are compiled functions. So, and the only problem is that we want to send to our test PID. So like the process that this test is running in, we want to send the event that we received to that PID so that we can do this assert receive, right? So what we need to do is take advantage of this fourth argument that we've been ignoring. So let's pull this out, and let's just say test handler, and this is going to take event measures metadata, and then the config can be anything. We're just going to say test PID, and then it doesn't have to be bound in the in the closure. We can just pass an anonymous or like a functionized thing to, I don't know what I'm talking about. Tell me what I should say here. Okay, so we're gonna do this. Test handler 4, okay, and then we're gonna send self as the config, and let's run that test again. No, it's not. Did I not save? I saved it. Module. Okay, so now it's no longer complaining about that. I didn't realize I had to fully qualify it. Okay. So that's an improvement. What else should we do to make this better? Now we have telemetry and path params running async. OpenTelemetry is the only one that has to be, or can't, the test suite cannot be async. Okay. This is good. And then just out of curiosity, I'm going to comment this out and see if we get those failures again. I suspect we will, because nothing's changed. Yeah. Okay. So, well, that's interesting. Oh, right. There was a bug in our test from before. So let's fix that. Where is that bug? We're passing path right. So we need to make sure that this is a string. And that's probably something that we can do in the path params middleware. But this is really just testing that we get a span that has the parameterized URL and not the fully filled in URL. So we're not really testing that. But we might want to make it safe to pass terms that are not strings or not charless as path params. You can think of something like, oh, well, I have some local information in my service related to a particular user ID, which happens to be an integer in the database, or a UUID or something that's like not really a string. Then let's make sure that when I call this thing to get information about this entity from this other service, that I'm using the same ID anyway. Like, there are all sorts of scenarios you could think of where we might want to make sure that this is a string, and we might want to coerce it to a string. But I don't know that this kind of strawman test, is enough to really justify making that kind of change right now. Let's see. Can I run tests with code action? No, I cannot. Okay. And let's just make sure real quick that those still fail. Yep. You also notice that these run at the end. So whenever you have XUnit suites, some of which are async and some of which are not, the non-async ones, the sync ones, will always run at the end. Okay, so we are still not getting the span messages. So I think what might be interesting is if we do, well, we can take a couple directions. One I'm thinking is let's run the Hardhat app with IEX, for instance, and make sure that and run it in test mode, right? And then we can do some of these steps, and we can open Observer and see that it's collecting spans. Like, make some dummy requests and see that it's collecting spans. That might be a good place to start. And if it's not, that might indicate that we are doing something wrong in the setup. And if it is collecting spans, then we're doing something wrong here, probably. And we need to figure out what's going on in here, and we might throw in recon to get recon trace, perhaps. See if it's actually calling this exporter module. I think, before we go for the whole like run it interactively, maybe what we should do is just let's pull in recon and see what we can do in terms of whether this PID or whether this module is actually getting called. So we'll set up a recon trace that'll print out something. Okay, so are you familiar with recon? If you're not, you should be. Let's look at recon. Okay, so it's specifically designed for production use. So we can do. All right, so. Okay, so let's look at the API reference. Recon trace. So these are going to be in Erlang. But what we can do is we can do something like this: recon trace calls. And yes, there was a similarly named conference. That was with an I and not an E. So we could do something like this inside our test. And then and then we can see if it's actually getting called. So let's do that first. So we need to get not Emacs. We'll come back to you later. Emacs. Said okay. So let's go and mix EXS, and we're going to add recon. And what version we got? 2.5.3. 2.5.3. And for now, we'll only do that in test mode, and we'll remove it later when we figured this out. I actually wish that there were sort of a sort of like archive install that you could do with recon and just call it with it being on the path. I might look into that later, but for now, let's just add this. Okay, let's just run test, and it compiled recon. Okay, so we're still getting that failure. Let's go back to the OpenTelemetry test. So what I want to see is at the start of this, let's do recon trace calls, and we're going to say OTel exporter PID. And I think I need to look at what that module exports, or what its function calls are. So we're going to have to go back over here. Yeah, RIP, Recon Distributed Systems Conference. Okay, OTel exporter PID. Okay, so we want to trace export 4, right? Okay, and then export 4. Okay, so calls. Right, and then let's just trace it for one call. And then C. Oh, whoops. I need to qualify that. We're not in Erlang. That's an atom. Okay, we're not getting anything printed. Let's look a little bit more at this function, the calls function. Okay, and I do recall something about this return trace that you have to, it's actually just an atom, and I don't know why it has the, you can't actually call it from that. Because it's actually a, this is like fun to MS, and that only works in the shell. So you can't do, I mean, we could do something like that, I suppose. We could, in our setup function, do IEX pry, and see what happens. All right, so let's jump down to calls here. Right, it takes a spec, options. So all calls from the key module, 10 calls printed at most. The other possibility is that we're getting our output swallowed. Because we're running in test mode. if anyone has ideas on that, let's. Let me know. Otherwise, I'm going to dig through the docs here. Okay, those are options. Okay, so by default, recon logs the current group leader, usually the shell. So maybe what we'll do here, let's see. So max options. So we can add, this is the 2-arity version. We were looking at the 3-arity version docs. So we can say IO server standard IO. Or is it just user? Let's try that. Okay, so we're not getting even that trace working. So maybe let's ratchet up another level. Go pop the stack a little bit. Let's go to batch processor and look at what it's doing. Because yeah, by the way, this I mentioned this to Brian Nagley, but this does not help. Okay. One thing I did consider trying is that we did call a force flush. I don't recall in my previous versions of testing OpenTelemetry whether we had to do a force flush, but we might try that. Let's give that a like 1 millisecond should be enough because we're waiting a whole second here. But if we do OTel tracer, this comes from somewhere else. Force OTel tracer provider force flush. Let's try that. Let's skip this test for now so we can focus on just one. Maybe we can get. No, mailbox is still empty. Recon trace is not printing anything. Okay. Actually, let's switch this to. Let's make it a bit more broad. OTel batch processor. And then let's match anything and anything and max of 50. And let's see if we can get anything printed out to the console. Okay, so recon trace is working. Let's look at what the printout is. So yay, that's an improvement. Can go up all the way up to the top, please. No scroll bars in this. Okay, so it was shut down first of all because we exited OpenTelemetry. Then it's checking the exports. It's starting link. Okay, so name global, it has no exporter. That's interesting. So maybe there's something wrong with the way we're configuring it. And schedule delay milliseconds. Yes, recon is the way to debug things in Erlang Elixir, or rather, it is highly recommended. You can use the Erlang tracing directly, but recon ensures that you don't create something that will take down your production system. So this is really good if you're connecting to a remote console and you're like trying to figure out what's going on the production system. You can run short recon trace output and see what's being called. I've used this in the past. We were at a past job, we were running an API service that was exposed to our partners, and we were trying to figure out why their requests, excuse me, were not being authenticated. And we had kind of a silly API key distribution scheme at the time, which I'm not real proud of, and I don't know why we did it that way. Had something to do with like the folks that were managing our gateway. That it doesn't even really matter anymore. But what I figured out was I traced the API endpoint with Recon, watching for particular things that were being called, and I found that what was happening was these people were actually an intermediary. The people who were calling our API were an intermediary for a third party. So they had their allocation of API keys incorrect, and what they were calling for, for partner A versus partner B, they're using the same API key. And it's like, no, you need to use different API keys for each of those partners so we can distinguish them on our end. Anyway, long story short, Recon helped me out in that situation. I highly recommend it. Now, note, it's going to format things like Erlang. So we're not necessarily going to have the pretty Elixir that a lot of us are used to, but it's good to familiarize yourself with that anyway. Okay, so we can see here that it has no exporter when it starts up. So like here it's stopped. This has got to be the application starting back up, right? Exporter is set to none. And then, yeah, it's really hard to build something like this. There are very few languages and environments that have this sort of runtime introspectability. I've seen people attempt it with Clojure, with JavaScript. Like if you're running a Node service, you open a socket that gives you a shell. But yeah, there's almost nothing like this on anything else. So okay, so we are entering. So the batch processor is a state M. It's entering the idle state. It's calling on start. So here is a span. So we are creating this span, but you notice the export is still none. So I think the problem is really in our configuration, and I think that we need to figure out why the exporter is none right now. Okay, and here's the end of our span. So we're actually filling in, the stuff that we would expect. And then we called force flush. This was us calling force flush. And then it calls exporting, and the exporter is still none. So I think we've found our smoking gun here. So let's figure out why. Okay, interestingly, so we are setting exporter here. If we go up to the top, we can see it's starting here, global exporter. Now, this is also the other thing, exporting timeout. Okay, that's fine. Scheduled delay millisecond we set. Right, we set that right here. 1 millisecond delay to export. Why is exporter still none? So remember we did set this over here. Traces exporter none. I wonder if what we need to do is something like this, but in our test. So let's go back over here, and we'll leave that. Let's do, because that config basically does the same thing. Open telemetry. It says traces exporter. I don't know if this has the same format because I know that they kind of make some shorthands for things. But let's just copy this in here. And then I think what I want to do is, because this stuff is set on startup, right? Let's look for hotel batch processor init, and then and let's see what it's getting passed when it starts up. Go away, shell. Okay. Right. Okay, so if we trace just the init on it, we should be able to see that it is hopefully initializing with the correct thing. Okay, so interesting. Note that our test didn't fail anymore. We got called init with hotel exporter PID, the test. All right, so let's remove the skip on this one and see if both of them pass. And we should see it start and stop, or should see it stop, and then yeah. So we got also confirmation that this was successfully initialized. So that's good. Let's run it again. Okay, so we're seeing both of them note the different process PIDs each time, and we got the spans that we were expecting. Cool. Okay, so that was a little weird. There must be, and I think that means that this bit is not relevant anymore. Yep. And I think, it might be good for some other session to figure out why this has changed so much, and whether the tests over in OpenTelemetry Tesla that we were cribbing this from, whether those are actually broken or not. Okay, so yeah. What did I do? Oh, okay. Here. Z, come back. Okay. So I think we can remove. Yeah, let's remove the recon trace calls. And then in the. Nope, don't want that. No, F. No. I'm still learning the key combos. Find in project. Thank you. Mixed up. Nope. Fine. Never learn new editors, kids. Stick with the thing that you always used forever. Okay, so we're going to remove recon from the dependencies, and I'll just kind of leave it in there in the list in case we need to use it again. And let's mix format our project, mix format, and using cargo. Sorry, folks. Okay. And let's make a commit. So recon is now in our mix.lock. I think that's fine. And then we restructure the test. So this is a good time to commit. Test middleware. Cool. I'm really glad we got that figured out. The takeaway is always use recon trace to test your assumptions. Okay, we're going to restructure and fix the OpenTelemetry, restructure the test suite, and fix the hotel tests. Okay, and let's push that. Cool. All right, real quick, let's look at my org mode. So we did our test suite cleanup. Do I still need the config line? That's an excellent question, Sam. I think it's wise to have it because otherwise we start up with the OpenTelemetry protocol exporter, which uses gRPC and all that goop. And I really don't want to. Because that requires an additional dependency. Like it's actually a separate file or a separate app that you have to add as a dependency, and we just really don't care what people use for their exporter. We just need the thing for testing mode. So anyway, I'm gonna leave it. We could potentially move this stuff to our test helper, but for now this is safe. Good call out though. Okay. Yeah, the heavyweight exporter, and also that thing is a booger to configure, and I really just like, why? Don't need to. Cool. Okay, so we checked off the first two bits. So I think this is a good time to switch gears a little bit. So let's look at decompile. And the reason why I want to look at this is, one, I need to refresh my own memory about how these macros are put together, especially Tesla's. Tesla's macros have a lot, right? And it's important to know that, so as we add additional features to the client, that we get the right output. And I think in our first or second session we had some issues with the order of middleware, and having the expanded output, or even the generated Erlang code, would be really useful for debugging that sort of thing. So what I'm going to do here is, this is one thing we had in the original that I told people, do not use this. Make your own client, please. Do not use the default one, because you can pull in, for example, HTTP poison to any project and just go HTTP poison.get, and that's fine. If all you need to do is make one request in a script. But if you're running a production service, you really should have a connection pool. You really should have all these other things. And you should, customize your client to be relevant to the actual thing that you're calling, right? So we're going to do this. And what this is going to do is this is going to take all the macros that we do in Hardhat Builder, and then it's going to generate a client just called Hardhat. So let's recompile. Okay, so it just compiled the one file, and then we're going to do mix decompile to expanded, and we're going to say Hardhat. Okay, so this made a hardhat.elixir.hardhat.ex file. Let's have a look at that. Okay, so this is why you love this. This is really useful. You can see here we are getting generated a whole bunch of functions by the Tesla builder. Right, so all the request stuff, the things, the different methods. So trace, put, we should see get, we should see post, etc. So this is all the different variations of ways that you can call things. And here's where our stuff starts. So pool options. Let's look at our builder real quick. And what we're going to do is we're going to split. Okay. So if we look at the builder, you can see one of the things that gets put in here is def delegate pool options. I don't think I saw the child spec. Let's scroll. No, all that's generated by Tesla. Right? Okay, so pool options. So this is the def delegate. And then, I don't know, I think maybe what's happening here is that decompile is ordering these somehow. We'll see. Okay, and then we keep going. Pool patch options. It's putting all the public things first, right? Okay. get delete. I don't know why these are in reverse order, but that's interesting. Okay, so here's our child spec function. And then it has a default option as well, so if you're not passing anything. And that's where it's creating the child spec for our hard. So you notice that our module is named Hardhat. The Finch pool is named Hardhat, and the ID of the child for the under its supervisor is named Hardhat. Okay, and here's our using macro. Right. Okay. And here's the middleware that we generated. So that's with no modifications. So this is not like we made a custom client that had its own stuff. This is all the stuff that comes at the end. And then you can see the adapter call here. This macro that is exported by Tesla has created this adapter function, which is appended to the end of the middleware when it executes a request. So cool. There's still some magic that is hidden inside Tesla, but we don't need to worry about that right now. And I think that's good to check up on that. So we'll make use of that again in the future when we add things to the client. Okay, and let's delete that file. Excuse me. Okay, and yeah, let's just make a real quick commit. Provide a default client in the Hardhat module. Now, even though this is providing a default client, you still have to start it. So even if this is like not something that we want to advise people to do, people still have to call, like start link or whatever, right? So you're still required to start the pool, otherwise the client won't work at all. All right. Okay, so our next and possibly final task for today, maybe we can pull in some other stuff. It's only been less than an hour. I honestly thought that especially fixing the open telemetry test would take a lot longer because it was so vexing that first time. All right, so let's talk about circuit breaking. And I think this should not, I feel like it should not be controversial, but it is for some folks. Let me set it up like why we have circuit breaking, and then we'll go into adding it. Okay, so one of the path, if you're running a bunch of systems, like a big, I don't want to use the word web scale. Gosh, that's so awful. But you're running a big infrastructure. You have lots of things going on at once. The worst thing you can do for your customers, for the consumers of your API, whatever, the worst thing you can do is be unresponsive. So if there is a case where something is not going to work, you want to detect that as soon as possible, so that you don't attempt to do it when it's just going to fail. The other thing to think about is that let's say my old Basho buddies will recognize this. Let's say a really popular internet celebrity decides to tweet that they're using your app. Well, maybe they're not on Twitter anymore. Maybe they're on Threads or whatever. But they broadcast that they're using your app. This is going to cause a thundering herd of their followers on your app. Things are probably going to break. You're going to be scrambling. And let's say what happens is you've got something serving your website that provides the app that is suddenly so popular, and you've got three or four backend services that supply information for that service for the front end, and you need to make sure that when you make a request to one of those backend services, that you can like reasonably expect that it's going to return a response that is good. And now, if you can't get that, like if you can't say this is going to return a good response, should you try it anyway? Yes, Justin, that was a horrendous Thanksgiving Day, one which my wife will never forget, lives in infamy. But anyway, so in this sort of situation where you're getting hammered, your service is getting hammered, and not from drinking too much liquor, uh, from just getting way too much traffic, things will probably break that you didn't expect because you didn't have that sort of stress on your system yet. So you have a couple options when something breaks. And we'll probably, I hope we'll have time to get to the second one. But let me allude to it first. One is, well, it didn't work the first time. So after some delay, let me try it again. That's retries. Okay. So that's one sort of resilience technique, is that, if you didn't get the result that you wanted, maybe you try again in the future, and then that gives you, a result that is acceptable. But when something is just, say, returning 500 responses every single time you call, you're not going to get a good response. You're not going to be able to service that, that client, right? And Sam alluded to it already. The problem here is that if you don't stop, you might make things worse. So hopefully somebody's on call, or responding to the issue, and they're trying to figure out why something is broken. If you're not letting up, that thing is going to get worse, or it's going to be impossible to fix. Thank you, Justin. That is an excellent metaphor. Nothing makes a jammed printer start working better than hitting the print button a few dozen more times, right? So like, it's the old adage of, patient comes to the doctor, it hurts when I do this, and the doctor says, well, stop doing that. So circuit breakers provide a way to stop doing that. So how do they work? Generally speaking, what they do is they keep a record of, so you have to specify for a circuit breaker, did this thing succeed or did it fail? And deciding whether it succeeded or failed is really important. It's important to decide what you consider a failure versus something was slow or something gave me an unexpected response, because there's a lot of nuance in there potentially. But say, for instance, every time you try to connect to this service, you get connection reset, TCP connection reset. That's a reasonable signal that that thing is not accessible, and you should stop trying to make calls to it. Now, if let's say you put this in there, what are the benefits aside from just not like making things worse? Well, you might actually actively make things better for your clients. So if you're making a call to some service that has a problem, you can't handle that part of the request, maybe you can respond earlier to the customer, to the client, and say, hey, this part is not working. Or you might be able to say, well, I can't give you this information, but I can give you this information. So there are whole sets of like design spaces that open up when you introduce circuit breaking. And if something is really broken, hey, you can alert on circuit breaking. One of the things that we did that I loved was we just track how many times our circuit breakers flip. And then we record that in some metrics, like we were using Prometheus at the time. You could also add it as an event on. You could add it as an event on your tracing span potentially. So maybe not the one that we're creating here. That's something that we could consider. Maybe we don't do that, but maybe what we do is there's a parent span, right? And we say, hey, this circuit breaker was flipped when we made this request. That's an event that is nice to track, and that you can set up alerts on, or helps to diagnose what a potential customer problem is. Anyway, so I hope I've motivated circuit breaking. I will say, just like, there are probably ways to make this be automatic. I'm going to go ahead and say there are ways to make it automatic. But I think it's also important to get experience with the less automatic way first. So we're going to introduce a circuit breaker into our stack. And we are going to use one that you have to manually tune. So how do you manually tune it? And here's where you take another drink if we're starting a Sean Cribbs code stream drinking game. How do you tune it? Well, maybe you should look at Little's Law. And that is to say, what is your capacity? Figure out what your capacity was. And then figure out how many errors you can tolerate within that capacity before you decide that this thing is not acceptable. And so here, this is hi Leaf, welcome. Before I go on and start the coding, let's read what Leaf said, because this is really, really interesting. I wrote a circuit breaker once, and I never felt like I had a satisfying principled way to detect when to start routing requests again. It was basically deciding between once in a while routing a client request through and seeing if it seemed healthy again, or implementing some kind of synthetic health check, which didn't feel suitably generic for what was otherwise a generic HTTP only aware library. What do you tend to do? Okay, so this is a very good point. The static configuration way, which we're going to start with, is very context dependent. And yes, I agree. The only way to know whether it's good again is to attempt. But the idea of the circuit breaker is that if you're cutting off enough, you might give a window of opportunity for that thing that is broken or otherwise overloaded to have a chance to catch up, or to be able to respond to requests again. So it's sort of this like knob that you tune. And maybe what we'll do, I really like circuit breakers for the sort of it's like the fire alarm, pulling the fire alarm, in that you can just turn it off. The other thing that is nice from a production standpoint, specifically with Erlang and Elixir, is that you can manually turn something off. So you can go and say, flip that circuit breaker, just like turn it off. And then everything will fail regardless of the health of that downstream thing. So that can be useful in incident scenarios. On the other hand, there is a technique which I think is probably better long-term, and maybe we'll do that in a future stream, which is automatically adjusting. Yes, take a drink. I'm about to say back pressure. Back pressure comes from control systems. How do you determine whether a system has capacity? Well, you attempt it. And if that succeeds, you attempt a little more, and so forth, until you reach the limits of that system, in which case you back off. This is, anyone familiar with TCP congestion control? This is called AIMD. So additive increase, multiplicative decrease. And there's a great talk by John Moore, a former boss of mine. He says, stop rate. The talk is from Strange Loop a number of years ago. He says, "Stop rate limiting" is the title of the talk. And what he suggests there is you don't need static rate limits on your services. What you need are adaptive rate limits. And the way you do that is you count successful requests, and you keep adding capacity. And really, I don't want to dig too deep into the implementations of these things, but to Leaf's question, the general strategy is you count events, you keep track of them in a history, and you have a sliding window of events. With the AIMD, don't think you need as many. I think you just need to keep a count. And as soon as you have a failure, you back off by your back off factor. But with Fuse, which we're going to use for circuit breaking, and circuit breaking in general, you keep a window of events, and you have a threshold of how many failures within that window do you accept, or what above that number of failures, then the fuse blows. Okay, I say Fuse. Circuit breaking is the term, Fuse is the name of the library, but the metaphors kind of cross over. Okay, so we're going to we can switch here. So let's look at Fuse. This is a pretty well tested library. I've had really good success with it in the past. Note this is a circuit breaker, not a file system in user space. There are a bunch of implementations of circuit breakers in Erlang. The other one that is more like what I discussed previously, the adaptive circuit breaker, is called regulator, which maybe that's even better to do. But Fuse, hey, we're going to go with easy today. Fuse already has an implementation in let's see, Hexdocs in Tesla. So we don't have to write our own. And I have contributed to this implementation, in fact. So middleware, Fuse, circuit breaker middleware using Fuse. So let's add that to our dependencies. And then the challenge here is going to be setting all this goop. And we'll talk about this stuff. Okay, so we'll also definitely talk about configuring this. This is the most important thing that you configure. The other stuff is like, let's talk about mode. And I don't recall why we had to do that. But this is a field that you should expose. Basically, it determines whether you are serializing all the requests to the circuit breaker or not. And you can use this async dirty. You can be writing dirty. It just checks the ets table, basically. And so you may have the fuse below multiple times within the same window, just if you're in this mode. Or you may have events that are in the table that need to be purged on schedule, but they haven't been purged yet. That's another possibility. Anyway, okay, so the options for this are, we need to name it. It defaults to the module name. I think we'll probably just keep that. Yep. Then we have to pass these fuse options, which we'll talk about in a second. Keep in original error, Boolean to indicate if, in the case of melting, it should return the upstream's error or the fixed one, error unavailable. Okay, so I think we'll probably want that to be true by default. And then we need a should melt function. And let's see here. And then have the query the fuse, sync or async dirty. I think we'll probably use async dirty. The main problem with sync is that, let's say you are your primary upstream or downstream service that you consume, you're doing like hundreds to thousands to tens of thousands of requests per second. You don't want to serialize all of those through this fuse. So, because it can be a real throughput limiter. So yeah, we'll probably make async dirty the default. Okay. Get you bright and dirty. All right. So let's go ahead and make in defaults for this. And we'll say, and this will be something we can override in our fuse options. Overrides. Okay. I don't actually know that we need this. Let's just have it have no arguments for now. And this is a prop list, not a map. Okay, so we don't need to override the name, right? We'll just let that be the module name. Interestingly, that's something that we can take advantage of later if, excuse me, if we need to emit events or whatever. Okay, so we need an ops, and this is going to be completely arbitrary. We need a standard here. This takes two numbers, and we'll talk about that. And then it says reset and takes another number. Keep original error, we want true. This will have some interesting interactions with retries. So it's like, which one was the keep original error, not keep original true. Which one was the original error? Like, was it on the first request or the last request that you attempted? Should melt. And I think that what we're going to do here, we're going to make a should melt function. I don't recall if this, we need to, here's a thing that might be interesting. Let's do this a little bit differently, right? And I'm gonna comment this out for now, because I think what we need to do is we need to do it here. And yeah, let's do it here first, because I don't recall whether we had and what we can do is module should melt one. What this will do for us is it will always call the should melt function in the module that we're compiling. And we can verify this with the decompile, right? So we're adding new stuff here. And let's make sure we get all this stuff. Mode, async dirty. Okay. So let's do should melt env to hardhat.defaults. Okay, and then we can override should melt. Okay, so let's talk about this, and then we'll go over and we'll implement should melt. And I think this has a default, so it might be good to look at what this does inside the code of the middleware. Right. Okay. So really, this is the most simple should melt. And it's actually a pretty good one. This says you only melt when there are TCP errors, basically. So if like it's a protocol level error and not a semantic error, it's not a 500, it's not a 40 whatever. Um, that's a pretty decent baseline. But I think what we want to do is get a little bit more nuanced about it, and start looking at response codes, because um, that'll give us an idea. Like, let's say this service we're calling is behind a reverse proxy, like it's behind an ingress controller in Kubernetes, or it's behind an Nginx, or some like hardware load balancer that can respond with a like 503 response code, or something like that. Then that is a sort of like indication that we should not consider that thing to be in good health. So that's a good reason to no. So like let's talk about these terms for Fuse real quick. So Fuse has three things that you basically do. You can ask, is this circuit breaker open? So is it ready to go? And that's what they're doing here. So they've set up all this context, whatever. That's just options. Says, okay, so if the fuse is fine, just run, right? The other thing it can be is blown. The fuse is blown. This means you've hit the error threshold, and you should not make it. So it will return immediately with error unavailable, right? And then there's another, like, if it's not found, then install it with these defaults. And right. Okay, so this is like if you didn't provide ops, it's just going to use this compile time default, which is not suitable for production use. By the way, let's talk about this because I keep dancing around it. This means we have a standard circuit breaker. The only other one available is a fault injection one you can use for testing, and I've never seen used, so don't use it. And then you have 2 failures within 10 seconds. So the time unit on the beam is always milliseconds. So if you have 2 failures within 10 seconds, which is not many failures, and then your circuit breaker will blow. It'll be blown. And then you have a reset period of 60 seconds. So I think that generally speaking, I've made these numbers quite a bit different. So let's go ahead and write our defaults and then we'll come back to this. So I think something more like 100 failures in a second is more reasonable, and then a reset of 2 seconds. Maybe 50. I don't know. Like maybe we can be a bit more conservative. So this will be, if you have 50 requests a second and all of them fail, this circuit breaker will blow. That's not too unreasonable, I don't think. All right, what is the LSP saying? Okay, so we're missing that function. Cool, we knew that. Okay, so let's look at our defaults, and we're gonna need to provide a way. Sorry, we're gonna need to provide a way to override these options. And this is one thing that I don't really like about the way Tesla provides options to middleware, is that they're done at compile time. And I think that some of them need to be done at compile time, but a lot of them don't. And things like this, I would totally expect that we should be able to configure that at startup time, right? Or we should be able to tweak that maybe not this, but maybe we should be able to tweak the mode per request. maybe we want some of our requests to just go through as fast as possible, but some of them it's like, yeah, we need pretty good assurance that this thing is actually working before we call it, and we want to use a different mode. So I don't recall the tech. I did have a solution for this in the original Hardhat, but I don't recall what it was, and it had something to do with mixing runtime and compile time options, and it may be something. So like last session we did not this, but we did the path params middleware, and we basically wrapped it. So we took the options. We did some intermediating here, and potentially what we could do is something like this, where we wrap the Fuse middleware and we tweak its options in the middleware stack. And that way we could allow them to have compile time default. So if they don't supply anything, we get the stuff that we expect, but then have something that is a function you can call in the client module that gives you the options that you want for Fuse. We might consider something like that, and of course then it could be overridden with whatever you put in the request. Okay, Bjorn, we have options. Okay, so this is a pretty good place to start, though. Let's go to defaults, and let's go ahead and make... Whoa, why'd you delete that? Okay. Let's make a function, a should melt function. And let's figure out what cases it should melt on. Ticktorp Island, yes. Okay, so default implementation of the melt test for circuit breaking. This function will cause the fuse to melt, the circuit breaker. Let's be consistent here as much as we can. To record an error when the response, let's see, the result of a request, because it's more than just a response. We might have a TCP error, right? Is nope. Okay. A TCP level error econ reset. That's a good example. Or econ refused. Right? HTTP status where the called service is not available. So greater than equal to 500. I think that's reasonable. What are the other possibilities? Like, I think that the only other status code I might consider for default, and I'm trying to remember if I did this in the original Hardhat, but is a 429 too many requests. So yeah, because that can be given by a lot of intermediate HTTP infrastructure that's not the origin thing that you're calling. So yeah. I think that's a pretty reasonable, because that is feedback that the called service can give you that you're overloading it. So I think that's a pretty reasonable rubric for when should melt. And this is we'll pattern match on the head here, and we'll say error. That's always true, right? Should melt. Okay. Then we have the response. And so let's do something like env. I don't know if that'll help. Yeah, that helps. Okay. So we can say status greater than or equal to 500. And I think that, let me see if it'll let me jump to the definition of Tesla env. Yes, okay. So status is an integer or null. Okay. So status is greater than 500 or status 429. Yeah, so throw out in the chat if there are any other reasonable status codes that we should fail on, in terms of that, because like I think there aren't that many in the 400 range, right? Because those are client errors, not server errors. Let's see. Let's status. Y'all can see how horribly I type. This is the joy of live coding. Yeah, so that's a good question, Sam. The question is, one question I have is more about principles. Do you want to fail if the client is making bad requests, or do you want to fail if the server is not there? I can sort of see the answer might be both. Yeah, so remember, this is not a correctness thing. This is an availability thing. So we're talking about liveness in this sense, and not safety. And this is about, well, we know that if the server that we're calling is not, it can't respond, like it has internal problems, so that's a good reason to cut it off. Or it has proxy level problems, so the proxy that is in front of it is not letting requests through. That's a good reason to cut off. The other one is like, this is more, this is more nuanced. 429 too many requests is like, hey, I can respond, but I'm telling you you're doing too much. It's more of an active back pressure rather than the kind of passive, oh, I just observed that there were, problems with that server. So I think it's probably debatable, like whether to include 429. My feeling is and this is even perhaps more important for retries, and we'll look at that potentially if we get to retries. And we're at 5 o'clock. We're probably not going to do that today. I'm only going to go for another half hour or so. But definitely on retries, one thing that we did was, if so this is like a third-party service, especially they have an API gateway or something in front, and you get a 429 from that service, then we should probably look to see if they have something like a retry after header, which is in the standard, the HTTP specs. And if they have that, then you can say, oh, now I know the minimum of what my delay for my next retry should be. But there's also potentially a case where it's responding 429 too many requests because it is detecting an overload on something upstream, which is another option than just like 503 or whatever. Or is it 502's bad gateway? Is pretty typical on those. So we could say, um, uh, this is, yeah, again, this is, we're writing an opinionated HTTP client here, not something that's going to handle every situation. So that's also why it's important that we did in the builder, we're saying, yeah, let's define a default implementation for this. But then you can also override it. So if you feel like, hey, 429s, I don't want that to melt the fuse, um, then maybe you could, um, overwrite that for your own client. And so we're not like penning you into these are our choices. Um, but I think that we definitely need to, um, make this overwritable. So I think it's probably the next step. And I want to say what we did was, it had to do with module attributes. And yeah, so let's look at the Elixir docs real quick. No, not Rust. That's great. I love Rust, but that's not what we're doing today. Okay, so I think it had to do with something like define attribute, register attribute. Um, no. Um, there's also a callback. Oh, right. So we could potentially use the before compile to see if it defined, um, the attribute that we want to put. So like because this is compile time, sorry, because this is compile time and the Fuse middleware expects its options at compile time, we need a way for the person who's writing their own client module to override these options. Um, and the other way that we could do it potentially, we could do compile time env. So example of that, I really think we should do it with an attribute, a module attribute. But I don't recall. Okay, so put attribute. I don't recall whether this will show a compile error if you don't, like, yeah, let's go down and find that. Put attribute. Okay, is that a compiler intrinsic and I'm just stupid? Um, or is it actually in here? Okay, so here's put attribute. Okay. So there is this thing about warning, right? So if you register an attribute twice, here we can test this out, right? We can test out this behavior. Let's go back to here. Just say like foo is 1 and foo is 2. Okay, and then if we compile that, it's probably going to produce some warnings, right? Foo is set for never used. That's different than set twice. So we might be okay. What's going on? What's this error? Missing our private functions. Did we not save? We saved. We need. Let's mix compile again. Yeah, fine. Okay. Because okay, so what I want to get to is something like we can use like fuse thresholds or something like that, and then that lets them set it, and we can do. Let's move down here. We can do fuse thresholds, something like that, and then they can override it at compile time. It does kind of suck that you have to define this at compile time. Like, I would love to be able to get onto a running system and go, yeah, that fuse is way too flaky. So let's adjust the settings here by changing something in the application environment until my next redeploy. So I don't know. If you all have any opinions on this, please drop it in the chat. I think this will work. And then, because this is before compile, right? If they set it, okay, real quick, let's go back here and put our foo in here. Foo2, and that's like io.puts foo. Let's do io inspect. Right, so we can see it's 2, right? So I think it's fine to have this defined in our macro, and then have whoever is using the client just override it with what they want. An alternative we could do here is we could do fuse thresholds application.compile env, and then the problem here is, what app are we in? Now we could do something like it's always Hardhat, right? And then we say module, and then when you're configuring your app, it'd be like config Hardhat, and it should be like that, right? And then let's say we have a we have an OpenAI client, right? And then let's see. Key or path. So we might do like module fuse thresholds, and then we'll put the default in there, right? And then when you config it, you might say fuse thresholds. Well, you know, OpenAI is slow, so we're gonna say it's a standard, and we're gonna give like, 20 within 30 seconds, something like that. So I don't know. I have multiple feelings about this. any Elixir heads, if you in the chat, if you have ideas or thoughts, let's entertain those. Otherwise, we're just going to go with this, and then you know, we could even put this application compile env right in here. There's no reason not to. Again, though, that limits us to compile time, and I kind of would rather have that be something that you can have a default for but override it on your deploy rather than at compile time. Okay, I think I've ranted enough about that. Okay, so let's make a test before we commit this. Let's first make sure everything compiles, and I remove that goop from there. Okay. And let's format. Okay. And this is fun. We got 5 failures already. Okay. So here's a problem. This is not compiled because we didn't add fuse as a dependency. So let's add fuse as a dependency. Put it here. I want to make sure that that's, yeah, so like, because what happens is this is like, hey, did you load this? You know, nope, then you don't get this module at all. Okay, so let's see what version we are at on Hex for fuse 2.5. Okay, cool. Let's do that. I don't think that there's anything in there that would change with the Tesla stuff. Okay. Hello? Okay. deps.get. Mix compile. Mix compile, please. Okay. And let's run test, and those tests that we wrote previously should no longer break. Okay. We might want to deal with that before we wrap up today, but let's get a quick test in here. And let's make a new file. Fuse test. Okay. I think we'll be okay with async true, because I think we're going to only have one test. Although we might have multiple, in which case we might want a client per test. But let's just do the default here and see how far we get. Okay, and then we're going to need bypass open, and you know, okay, and then we're going to let's just copy this. No reason to not reuse that. And this is just telling me I need to have a custom test case template. Okay, so what do we want to test? There are a couple things that we should test here. And maybe let's just here's one thing I want to test. Let's first set the fuse options. Was that what it called? Fuse thresholds? We just did this a minute ago. Fuse thresholds. Okay. So let's make this really, so like 1 within 100 milliseconds. And the reset is, you know, a second. that way this is going to trip really fast. So what we want to do is, and maybe let's make it 3. So like we at least have to test that you can do it multiple times, and it's not going to trip after 1. Okay, so we want to let's have a test. So TCP level errors melt, say below the fuse. Okay, and let's do one, and let's like maybe have. Let's test the 500 errors, right? Okay, for status. So 500 dot dot 503 is probably sufficient. So HTTP blows the fuse, right? And then we'll go HTTP 429 blows the fuse. Okay, so this is really just testing our should melt, right? Okay. Okay, so this one should be straightforward. Okay, so we'll say, and all of these need the bypass. And we're going to expect, excuse me, I need to look at the other examples. Okay, so right, so we do something like this, except we're not going to, previously I would have done this with Tesla mock, but Tesla mock is awful. So let's see if we can do something like error econ refused. So something like a TCP error. Yeah, let's look at the docs real quick. So, okay. The challenge here is that bypass might not give us what we want to do here. And we need to, so like, a normal response is like fine. The other option is we can just call down and then it's not available, right? Like it's literally going to give us so let's get the port first. Okay, port bypass dot port, and then we can say bypass down, and this will just turn it off. So like you can't even make a connection to it, right? Okay, and then we're gonna go for let's do 3 times. Well, let's do it 3 times so we get 3 errors. And then we go, okay. All right, so we'll do test client.get. We'll do something like this, but it'll be actually, I don't know why I need to do this. This is like my Rust brain saying, "Oh, you've consumed that resource. You can't use it again." But we're in Elixir, so okay. So what we're trying to do here is call it 3 times, and we're going to get error each time. And I think let's look at Gen 2CP. So there should be there's a POSIX type in here. Can socket connect. Okay, inet POSIX. So it's going to be something like econ aborted or econ refused, I'm guessing. Let's assume it's econ refused, and we'll come back to it if we have to. Okay, and then the last thing we want to do is this should be after it's blown, right? So we had 3 errors within 100 milliseconds. That shouldn't be hard. And what we want to assert here is that the fuse is now blown. So we'll say this is unavailable. That's what the middleware returns, right? And let's run that test and see if we get what we are expecting. Okay, so we got a bunch of not implemented. Okay, so that's interesting. We get connection refused. So it's an actual string. It's actually expecting something different. Okay. It's possible that what happens is Finch uses the more friendly it converts. Where's dash? There's a thing. Right. So there's this table. So it might be doing this, just returning this string. There's a function you can call that if you pass it one of the error atoms, it'll actually give you a human readable string. So I'm pretty certain that's what Finch is doing, and that's why we're getting connection refused instead of econ refused as an atom. Okay, so here, let's focus this test. Okay, that's interesting. Did I not save it? No, I didn't save it. Okay. Okay, so the question in my mind here is, did we blow the fuse? Let's bump it up to 3. Okay, so it passed this time. You can't see it, but it passed this time. Okay. I think there's a question in my mind. I don't remember if Elixir ranges are inclusive or not. So we'll see. I think that's good enough to show that it blows the fuse. So we can probably do something like this again. But let's do it for these. Right. I made it return the original response when it blows the fuse, right? So, or when it melts the fuse, right? So if we look back at the Tesla, that's a good point, Sam. So down here in run, right? So if it should melt, and you say keep original error, it will return the response that you got from calling the rest of the stack. Otherwise, it's going to be unavailable. which is what you get when the fuse is blown anyway. The other issue is potentially we might want to do sync for the tests, because if it's async, it may take one more to trigger the fuse to be blown. So because we're using the async dirty mode by default, and let's test that theory real quick. Let's change this to sync and see what happens, because we should get a failure sooner. No, okay. Maybe I just don't know how to count. Off by one error. Let's ride dirty. Okay. So now we've got the basic like outline. So let's implement these tests. And these are parameterized by the status code. So let's say bypass expect. And we're not going to expect once. We want to be able to call it multiple times, right? So we'll say bypass fun, and that takes the con. And we're going to do plug.con.respond. Con status is status. Body is failed. We'll just say it's failed. Okay. And then what we're going to do is basically like this. We're going to run it n times, but this is going to be okay. And we're going to say tesla.env status is status, right? And then all of a sudden it's going to be unavailable. And interestingly, we can do the same for 429. So it might make sense to just make this an array, a list, 429, and then we can get rid of that other one, 500, 501, 502, 503. That's really what we wanted to test. And I mean, there aren't really, like, I think I have HTTP status in here. Yeah, HTTP status codes. Okay. So, you know, this really, like, internal server error, we definitely want to error on. 501 not implemented. I don't know that anything returns that unless it's buggy. Bad gateway, yeah. Service unavailable, yeah. Gateway timeout, yeah. 505, I don't think also. I think that also doesn't happen. Like who returns 505? Some of these are also, I want to say, like web dev response codes. So yeah, like this stuff. I hate that things like Cloudflare just invented their own status codes. That's not cool. Okay. So maybe what we should do is adjust our original assumptions. Like nobody's going to return 501, right? 501 not implemented. On the flip side, I'll just leave it. Like I don't actually think that there's any harm. Okay. Let's run those tests. Undefined variable status. Okay, now I need to refresh compile time versus. I think I need to quote this. Whoops, okay. And then I need to unquote it here. macros. It'd be nice if there were a like more direct way to do that, but let's see. One test. Did we not emit tests? Test verbose. B. Okay. I think there was one where it would print each test like on a single line. If anyone remembers that output, that would be helpful to me. I think it's with the formatter. Configuration, coloring. So we don't care about excludes, coverage. We're not computing coverage. Okay. Okay, it actually, well, no, it didn't run the test. All right, I think what we're gonna do is do it the old-fashioned way, which is not macros, and we're going to do okay. We're going to do this. 429. We'll make a function which is test should melt status, and we're going to pass it bypass. We're going to pass it 429, and then we'll make should melt status let's say assert should melt status, and then we don't collide potentially with the naming of functions in here. This is why we have functional programming. We don't have to do everything at compile time. Okay, so I'm going to copy this out, and there's our test implementation that we were trying to. We can remove the unquote. Actually, that needs to be pinned. That maybe was part of the problem. I don't know. Because we're matching on it. We don't want to override it. And then let's just copy this for each of the codes that we want to test. And then we'll be done for the day. I think it's pretty, since this is, you know, just copy pasting stuff, I can talk about what we might do next. I think, especially given Leaf's comments, it might be worth considering this middleware to be optional, and we can go do something more sophisticated with regulator. That also has some static like compile time tuning knobs, but it might even be more interesting than this. This is sort of the, if you want a baseline, you need some way to cut off calls that are going to back up your own system, or take down the system that you're calling. Um, Fuse as a circuit breaker is great, but if we're talking about, well, we don't know what our throughput is, we don't know what our capacity is, what our tolerance for errors are, then having it be adaptable such that it'll automatically throttle when things are going bad, rather than just cut it off completely, that might be better. Um, okay, and the folks, our buddies at Bleacher Report have made good use of that pattern. And one of the neat things they said about it is that you don't have to, like I've been mentioning, you don't have to know what your capacity is. What will happen is, as you start to reach the limits of your capacity, you'll run at like 99.9% of your capacity if you have enough traffic. And like the capacity that is derived from trying requests and seeing if they fail, um, it'll automatically bounce up and down around that limit, as long as things are going well. And when things go badly, everything automatically backs off, and you have the opportunity to take corrective action without it being constantly under load, which is one of the worst things, especially if you have like uh, a system that's really hard to scale, and it tops out easily. If you're trying to work on it while it's overloaded, it is just a nightmare. Like even getting responsiveness from a shell, like it can be a challenge. So, okay, so we've got some. Okay, so here it's interesting. We got error unavailable earlier. Now this is another thing where we're probably like hitting. We need to run this as async false. I don't really want to, um, but there's another thing that we might do, which is, yeah, and we do probably, because this has its own state, right? And that state is hidden. It's often the fuse process. One thing that we can do potentially, at the start of each test, and we'll need to look at the docs for this. So there's fuse, and I mentioned there's three things that you call. You call fuse ask, fuse melt. The other one is reset. So let's look at that. So yeah, so this will set it to be unbroken with no melts. This means that, um, we need to make sure that we're not running these tests async. Fuse reset test client, because that's the name of our fuse. Yeah, so you can see what happened here is our tests ran in a particular order. One of them passed. The fuse stayed melted. It stayed blown, and so we got error unavailable, instead of a status code. And then it did it for the rest of them. So we need to reset the fuse after each test, and now see they all pass. Okay. So it's, again, we could get around this by having a different client for each test. That would mean it has a different fuse. But this should work for now. Okay, let's look at our commit here. Okay, so we added a default module attribute. We'll need to add documentation for that later. We added the default should melt, and we made it overwritable. And then we added the fuse middleware. I think there's some things we might reconsider. This might be important to put at the bottom. It's like, because you might want to see spans even when the fuse blows. So that's sort of an interesting thing to think about. Um, and again, we may still want to make our own Fuse middleware based on the Tesla one for a variety of reasons, but we can cross that later. Okay, and then we added the default implementation for should melt with a little documentation. That's good. We added Fuse. It's in our lock file. And we have to add the tests. So there's our whole thing. And while we're at it, let's go ahead and add to the README that we completed that, and we can call it a day. Okay. Added Fuse for circuit breaking with defaults and tests. Okay, cool. Thank you all for hanging in with me for over 2 hours. I think I'm going to try to keep doing this at the same time. So if you want to come back, hang out, tell me how I'm doing it wrong. I appreciate that, and we'll keep on working on this library. And you can see that I do have other things on the agenda as well, but we need to support timeouts and deadlines and retries. That's the suite of stuff that came by default, I believe. We had some other things that were in there that had to do with, because we wrote our own OpenTelemetry middleware rather than using the one that's available in Contrib, because that wasn't available at the time. We might want to look into tweaking some of these things, customizing them a little bit. I don't particularly like the Tesla keys for telemetry. There's all sorts of things that we can do to improve upon this. Honestly, even without timeouts and deadlines, which the main reason we want to deal with that is we need to propagate the OpenTelemetry context. Timeouts involve creating processes, and so that context would be lost, and we need to make sure that it gets passed in after spawn. And then in the retries, there's a lot of nuance we'll have to talk about there with where do you put it in the stack. Do you create spans for each of those? What's a reasonable back off time? How do you grow that? Do you add jitter? There's all sorts of interesting things with retries. So I think a couple more sessions and we'll have all of these checked off, and we can maybe get it to beyond an alpha release. So thank you again, everybody. I'll stick around for a few more minutes for questions or comments. Otherwise, have a lovely weekend, and thanks for joining me. You're very welcome. Thank you for coming. This is session 3. I feel like I'm getting my Elixir legs back. It's been a while since I wrote it professionally, even though I love writing code in the language. So it's interesting to feel like I'm doing it again, even though I remember all the principles. The actual doing of it is different. How did the increased text size work for everybody? Is that improvement? It's like half the resolution I'm usually working at, but well, 1/4 technically, factor of 2. Good. I think on previous streams we had it was just too small, and so it was introducing artifacts. So I'm glad to hear that. Could even see it on your phone. Oh, that's great. So, I feel like I struggled with the font size being too big. Um, but I'm glad that worked out for everybody else. Cool. All right. Unless there's any last minute questions or comments, I'm going to end the stream. Thank you, everybody, and have a great weekend. Bye.